Welcome to this tutorial. I'm solving question number 7 of paper 2-1 Major exam series of 2017. The question is related to the motor effect, which is one of the electromagnetic effects included in the syllabus of O-level physics. The question says figure 7.1 shows a metal rod placed between the poles of a magnet. So we can see that there is a north pole of a magnet, there is south pole of another magnet, and the field lines would be emerging from the north pole, entering into the south pole here. And in this region between the magnetic poles, a metal rod AB is placed. End A of the rod is connected to positive terminal of a DC power supply. So this is end A of the metal rod, which is connected to the positive terminal, and B is connected to negative terminal. The current in the rod and the magnetic field produce a force on the rod. So whenever there is a current carrying conductor placed in a magnetic field, a force is going to act on the conductor, which is the motor effect. On figure 7.1, draw arrows to show. Number 1, the direction of the current in the metal rod. Label this arrow as capital C. So the direction of current is going to be from A to B, and this arrow is showing the direction of the current. So it would be labeled as capital C. The next part says direction of the magnetic field that acts on the metal rod. Label this arrow as capital M. Now the direction of the magnetic field is going to be from north to south, and this arrow would be labeled as capital M. So I'm making an arrow from north to south and I'm labeling it as capital M, the magnetic field. The direction of the force on the rod, label this arrow as capital F. Now we will be using Fleming left hand rule here to find the direction of the field. So the first finger would be aligned with the direction of the magnetic field. The second finger would be aligned with the direction of the conventional current flowing. And now the thumb will give us the direction of the force acting on the rod. So in this situation, the force is acting down the page or in this direction. So it will be making the rod move in the downward direction if the rod is movable. The next part says the power supply is removed and a sensitive voltmeter is connected between the ends A and B. Now we have removed this power supply. The rod is no more carrying a current and it is still placed in the magnetic field of north and south poles. When the rod is moved upwards or downwards, there is a reading on the voltmeter. So this phenomenon is called the induction. Whenever a conductor is moved in a magnetic field in such a way that it is cutting the magnetic field lines, then an EMF is induced in the conductor. So the voltmeter is giving that reading to us. Explain why there is a reading on the voltmeter. It is a 2-mark question or part. So we have to write a 2-mark answer for this. So I'm writing the rod cuts the magnetic field lines while it is moving. Due to which an EMF or voltage is induced in the rod. So that is why there is a reading on the voltmeter while we are moving the rod upwards or downwards. The next part says the reading on the voltmeter is increased by using a stronger magnet. State one other way of producing a larger reading on the voltmeter. So another way could be that we would move the rod faster in the magnetic field. So it will cut magnetic field lines at a larger rate. So a large reading on the voltmeter could be produced in this way. Here the question has ended and it was a simple question related to the motor effect, and there were 2 parts also related to electromagnetic induction.